Hi physics students, we're working on the AnsKey video for worksheet 2 in Unit 6, and this is just understanding relationships and vocabulary. So the relationship between period and frequency is that they are reciprocals of each other. Period is represented by a capital T, and it is the time for one cycle, while frequency is the number of cycles per second. So they're inversely related. Meaning as one goes up, the other goes down. The wavelength and frequency. So this is the equation that includes wavelength and frequency. Its velocity equals wavelength, which is lambda, times the frequency. And if we know that the velocity that the frequency doesn't change the velocity, then we know that as the frequency increases, the wavelength decreases. So this was a concept we learned in the Waves on a String lab, and we can also show it by finding the equation in terms of wavelength. If wavelength is equal to frequency, it should actually be velocity divided by frequency, then you can see that they are inversely related to each other. So in the same sense, frequency is equal to velocity over lambda. So inverse relationship. As one goes up, the other goes down. So wavelength and period, this is actually what you graphed in the Waves of a String lab, and you should have seen that as the wavelength increases, the period increases, so it's a direct relationship. If I were just to take this equation right in here and convert the frequency to period, velocity is equal to wavelength times 1 over period, that's the same as velocity, then you can see the direct relationship between wavelength and period. So if I were to rewrite it as period is equal to wavelength times velocity, since they're both in the numerator, as the period increases, the wavelength also increases. Another way to rewrite it is to show that period is equal to lambda, that's a lambda over velocity, and you can see that again, they are directly related. So direct relationship. Okay, in this next problem, it says a wave generator produces 10 oscillations per second. That is a frequency value. So I'm going to go ahead and I'm going to write out my givens. I don't know where I'm going to need them, but I'm just going to write them anyway. 10 hertz. The speed of the wave is 300 centimeters per second. I'm going to make sure to convert this. You don't necessarily have to, but the velocity is, that would make 3 meters per second. And now we have to solve for the wavelength. So the wavelength is my unknown. Well, I have my equation that velocity equals lambda frequency. If I know my velocity is 3 meters per second, and my frequency is 10 hertz. Then if I divide the two, I get lambda is equal to, so I'm just going to divide 10 to both sides, and I get 0.3 meters as my final answer. If you kept it in centimeters, it'd be 30 centimeters. Okay, what happens to the wavelength if the frequency of pulses is increased? Okay, so we know that frequency is inversely proportional to wavelength. And it says what happens to the wavelength if the frequency of pulses is increased. So if this increases, my wavelength decreases. So lambda decreases, which means waves get shorter. Okay, a wave on Beaver Dam passes two docks that are 40 meters apart. So I'm just going to draw two docks. I know the distance between these two is 40 meters. There's a crest at each dock and another 3 crests between the two docks. So I'm going to have a crest here and here. I'm going to have 3 more crests in between. And I'm just going to draw a visual of my wave. Now we need to figure out the wavelength. So to figure out the wavelength, I'm going to just start at a crest here, go from crest to crest. I know I have 1, 2, 3, 4 individual waves within a 40 meter span. So 40 divided by 4 waves gives us an answer of 10 meters per wave. If 10 waves pass, 1 dock every 16 seconds. So if it's waves over time, that gives us frequency. If it's time over waves, that gives us period. So if I calculated each of those, you could obviously calculate one and just take the reciprocal of it. It would give me 0.625 hertz. And the period would give me 1.6 seconds. So these are the two answers. What is the speed of this wave? So again, we have a frequency, which is 0.625. We've got a wave length, which is 10 meters. We've got a period, and you can include that also, but if we're solving for wave speed, I already know the equation is frequency times wavelength, or wavelength times frequency, and so I know I don't really need to use the period in this equation. So it's going to be 0.625 hertz times 10 meters, and that gives you 6.25 meters per second. All right, so the next problem is about Sally Sue, an enthusiastic physics student, enjoyed the opportunity to collect data for our standing waves in a spring. She and her partner held the ends of their spring 4 meters apart. There were 5 nodes in the standing wave produced, and Sally moved her hand from the rest position back and forth along the floor 20 times in 4 seconds. So this is going to give us a frequency. That is going to give us the total distance. That's 4 meters apart. And we have 5 nodes. Nodes stands for no displacement. So I'm going to draw held the ends of their spring. There were 5 nodes in the standing wave produced. In this diagram, I'm going to assume that the 5 nodes include the nodes at each student's hand. So I'm going to draw 1, 2, 3, 4, 5 nodes total. And then I'm going to draw my standing wave, which goes up, down, and then the reflected wave in dotted lines. So it's a very rapid movement where it actually looks like the wave is not moving at these high peaks. If she moves her hand fast enough, of course. So sketch the situation and determine the following. So this is our sketch. The wavelength of the wave Sally Sue sent we know that one wavelength has to go through 3 nodes. It's going to be from one rise, back down, and back to a node. So there's 3 nodes here. If we look at this total standing wave, I can see that there are 2 waves in this 4-meter distance. So if I were to calculate the total distance divided by 2 waves, I can conclude that there are 2 meters of wavelength. The frequency of the wave produced, I already saw that information there. We've got 20 cycles over 40 seconds. That gives me my frequency, which gives me 5 hertz. And then the speed of the wave. So I'm obviously going to need my wavelength is it's actually 2 meters. I've got my frequency, which is 5 hertz, and I need my velocity, which is what I'm solving for. So velocity equals lambda frequency. I'm going to plug in my 2 meters, multiply it by my 5 hertz, and that's easy to get a velocity of 10 meters per second. You can say 10 meters times hertz. I'll still give you credit for that, but you should already have memorized that the unit for velocity is meters per second. Determine the speed of the wave. If you double the frequency, you determined in B. So if I had double the frequency, remember the frequency, even though that value increases, the frequency only decreases the wavelength. It actually doesn't do anything to the velocity. So how would the speed change? It wouldn't change. It would stay the same. A wave generator generated standing waves on a string. Draw waves that fit the following descriptions and fit on the string. So one complete wave has 3 nodes in it. It goes up, down, and back up, and then it goes up, down, and back up for the reflected wave. 2 complete waves are going to have 6 nodes. So 1, 2, 3. Actually, 2 complete waves would have 5 nodes because one of the nodes is going to be connecting the 2 waves. So I've got 1 wave here, 2nd wave here, and then my reflected wave is my dotted line here. So 1.5 waves has 1 complete wave, so that would be 3 nodes, and then it has 1/2 of a wave, which would create 1 loop in a standing wave. So that would be 4 nodes total. It would be 1, 2, 3, 4. This is my first wave, and this is 1 loop, which creates 1/2 of a wave. So I connect that with my reflected wave, and this is what we call a standing wave. So just to be clear, this right here is 1 wave, and then this is just 1/2 of a wave, 1/2 of a wavelength rather. All right, hopefully that answers all your questions. If you have any more questions, just contact your teacher.